Our cube root graph is the inverse of our quantity cubed. Remember, our cubed is this green picture here. So remember, our inverses are reflected across the y equals x line. So we get this blue picture here. So this is our parent function for our cube root. Remember that parent functions are the ones what it looks like when there's no change whatsoever. We haven't shifted left or right, we haven't shifted up or down, and we haven't impacted the steepness, right? So this is our cube root graph. So it kind of looks like if you think like the moves for walk like an Egyptian, talk like an Egyptian that you make with your arms, it kind of reminds me of that, okay? Our pattern for finding this starting point, the vertex, is the same as we've had before. You do the opposite of inside the root, so it's the opposite of inside whatever function you are. So in this case, it's a cube root. And then it's the same direction vertically outside the root, right? And then we always have some a value pattern that we take into consideration, right? So our a pattern for a cubed was when we went up 1 and up 7, or down 1 and down 7 to make that discoing shape, okay? But remember, inverses switch their x and their y points, so that means here that we're going to do over 1 and over 7, or left 1 and left 7, instead of up and down, because we switch our x's and y's. And then our a value is still impacting the steepness, so it's impacting the y value. So that's how far up and down that you're going to move. So let's take an example of one. So here we're going to go the opposite direction underneath the root horizontally, so we're going to go right by 4. Same direction outside vertically, so that's up 7. So right 1, 2, 3, 4, up 1, 2, 3, 4, 5, 6, 7. Okay. It's a cube root, which means that I've got that kind of a shape going. We're going to go, the a value is 1, so we're going to go up and down by 1, and left and right by 1, up and down by 1, and left and right by 7. Because from your vertex, you're going right and left, or up and right and down and left. Okay? So then our picture goes up 1 over 1, up 1 over 1, 2, 3, 4, 5, 6, 7. Down 1, left 1. From that point, down 1, left 1, 2, 3, 4, 5, 6, 7. Right? And then we make that kind of curvature that we have to do like a sideways disco. Okay? Now, if you remember with your x cubes, your domain and range it was going all the way to the left and all the way to the right and all the way down and all the way up. So both our domain and range was negative infinity to positive infinity. If we switch to get our inverse, our domain and range switch as well, which means that it's just negative infinity to infinity and negative infinity to infinity, because they were the same. So here we're going all the way left and all the way right, and as we're going left, we're going down, and as we're going right, we're going up, right? So our domain and range is negative infinity to infinity, or you can write it as all real numbers. If we look at our next one, we're going to do the opposite of underneath the root horizontally, so we're going to go left 2, same direction outside of the root, so down 3. So left 2, down 3 puts us here. Then our 2, we're going to go up and down by 2, left and right by 1, up and down by 2, left and right by 7. So up 2, right 1, down 2, left 1, up 2, right 1, 2, 3, 4, 5, 6, 7, down 2, left 1, 2, 3, 4, 5, 6, 7. And then we create that sideways disco kind of shape. Again, both our domain and range are negative infinity to infinity, because we're going all the way up and all the way down, and all the way left and all the way right. Okay, so if we look at our last example, we're going to shift opposite of inside the root, so we're going right 3. Same on the outside of the root, so up 6. So right 3, up 1, 2, 3, 4, 5, 6. Okay. This one, notice we've got a negative, so we're going to go up and down by a half, right 1, up and down by a half, right 7. Okay. Or left and right by 7. Now, because our normal one goes this direction, when we have the negative, it will flip it so that it goes I drew that horribly. Goes like that. Okay. So instead of going up, where we would normally go up, we go down, and where we normally go down, we go up. So I go down a half over 1, down a half over 1, 2, 3, 4, 5, 6, 7, up a half, left 1, up a half, left 1, 2, 3, 4, 5, 6, 7. All right, so then we get this kind of shape where it's doing the walk like an Egyptian the other direction. Okay. Again, our domain and range are all real numbers or negative infinity to infinity.